Hello everyone, today I will share the technical topic with you about Android OTA updates, its internals introduction. This slides is not comprehensive because the research was pretty huge and the topic is also very complex. So I hope I set background for everyone interested, and you can continue on your own and also share later, maybe on the next Embedded Fest with everyone. A couple words about our background, who we are. So this research was started by my colleague Sergey Zherzherunov. He is BSP engineer at our company Sendersoft. He makes some initial research when working on his task, and later I continue this work and composed this presentation. Actually, I worked a lot previously with embedded updates because it's pretty common topic. I started from MCUs and later I moved to embedded Linux, and now we work on Android BSP, and also we face again here embedded updates. So I wanted to explain why this research was possible, what was the request for here. As you may know, more and more devices are running AOSP, and now it's getting into automotive, especially for infotainment in our case. And in Sendercom, we are a partner of Qualcomm, and we help Qualcomm customers to integrate Android BSP to their devices. Qualcomm provides their BSP, but it's like not finished product. It's only a background. And OTA updates is a common essential feature for every embedded system. So it also included in AOSP, but AOSP provides only a framework. It's not a ready solution, so you should base your OTA application on their update engine. And when we started to work on this task, we found that available docs is not comprehensive. There is not like docs about overall architecture, quick start, like only like scarce mentions about some functions. Then how we should implement this OTA on our site. And for our understanding, we saw only source code is our docs. So we started to dive deeply into them and build our understanding and compile also documents. And creating documents is not only good for our understanding, but it's also makes some advantage that we can later present them to our other customers. And actually we are doing these trainings on other topic previously. So we followed this approach and decided to share also with more broader audience. And here is quick facts about some background for this research. So our AOSP distro is provided by Qualcomm. It includes modification for Qualcomm SoCs, and the name for this distro is Code Aurora Forum. You can actually find this website, but usually it's very hard to use if you don't have any background. And our particular BSP is based on AOSP 10. The research scope included only full AB, that is seamless updates. This research didn't include incremental or non-AB updates. Non-AB updates is now like outdated. AB is the most modern. And incremental, it's another a little bit more complicated topic. So we started from maybe more easy and just try to implement full updates. And this BSP includes languages like Makefile, Go, Python, or Bash. Most of them are most of source files are written by Google, but there is some modifications from Qualcomm as SoC vendor also. And just for everyone's reference, maybe who is just starting for this topic, we provided the list of tools that supported our research. It was like double commander because we are using Ubuntu, and we also used Visual Studio Code for code analysis. There is some short mention about general OTA features. OTA updates were designed to upgrade only operating system, like the core parts of it. So that's why it updates the whole partitions, and these partitions are read-only. So you are make sure you are in consistent state. And for everything else, like user apps or read-write partitions, the other mechanisms should be used. And for AB updates, it's why it's called seamless, because you can update all partitions while the main system are booted. So the user almost doesn't see any obstacles from update process. And another great feature is streaming. You don't need to download a whole partition image. You just connect to the server and stream directly to non-active slot. So here is like the whole workflow overview. This slide is like pretty big, but I hope it helped everyone who is just starting. I maybe not go to huge detail here, but try to be to get some introduction. Who is not, for those one who is not maybe familiar with this topic. So Android consists of AOSP from Google plus vendor parts, because pure AOSP can't run on actual hardware. When you get all source codes, like the final result is you receive binary images for every partition. And there is a huge build system, and underneath of it, not only like source code, but the build system is also pretty complex. It includes make files and is based on Sunkati Ninja applications. These images can get into target device, which is depicted here in several ways. One way is to use vendor tools. This is this path. Another way, you can flash separate images with fastboot, which is a protocol and protocol implementation in desktop app for engineers. And our today topics is another way. You can go through OTA updates. It's even more complex because you not just flash like a standalone device with other tools. It's device updating itself. That's why there is much more complexity in this mechanism. When you have these partitions images in your out folder, you use some tools from BSP. Like here, I will describe them later in more detail. And you get OTA package, which is named update zip. And this package is different for different scenarios. For non-AB, it's produced in one way. For AB, it's different way. And then you apply OTA with your update client. Update client is developed by OEM. So it means someone who is using AOSP or BSP from vendor, and integrates to their device and their solution. You also need to provide the server, and this update client use update engine framework, and this way applies update to target device. Like I said, some notable features about this update is you have web partitions, so update engine just is running like a regular process in booted Android. You don't need to reboot to some specific firmware like was in all the versions. And one or other way, after you flash the device, you boot all these firmwares. So I will set more background for how OTA packages are built. There is Android short Android document, like it's not going into huge detail. It just provides you the commands. Usually it's make dist, and then you run OTA from target files. So it takes target files zip produced on previous step and processes make some processing and produce OTA update zip. So I will explain this in more with more internal detail on the following slides. If you are pretty new to AOSP engineering and hacking, you can run command So in this command is like shows you a sort of help from available building commands, but it's also not all that you have. Like many things are wrapped inside Google BSP. And the implementation of these commands you can find in build, make, and setup script. When you look into this implementation, you can quickly go deeply into all other things about Android build system. So talking about Android build system, Android includes more than 700 repositories. I just make here like detail of the list, and you can see it's more than 700. But everything is built with one M command or make. Actually, they are almost the same. And the build, initial build takes around 5 hours, but incremental builds are much faster. And it's interesting how it's possible, like build everything with one command and have so fast incremental builds. This is thanks to specific tools developed by Google for this purpose. So it includes Sung, it's specifically for Android by Google. Kati by Google, basically make clone. And Ninja by Chrome developer. It was integrated a little bit later, and there is also interesting history underneath it. And you may think, where is GNU Make? And everyone who may check Android sources can see many make files there. But for Android, the make is already like history. So the plan was set to move from it to different tools which will allow faster and more scaled build. Here also provided key partition descriptions, but I will not go to huge details here because this information can be easily found on the internet. It's here just for reference. And the next slide include more unique details. So as I mentioned on workflow slide, how you can build OTA package. According to this document, you should use these two commands, but what's underneath these commands, and if you need to do some modifications or debugging, you don't know, like, and there is no documentation. We tried searching on internet, maybe only some excerpts, but usually they are outdated for previous Androids, like 7 or 6. So make dist produces the directory with portion of the build for distribution. It's also configured in makefiles. So here is actual make dist implementation. Like this is not full source code. This is just the most essential parts, and some code is missing from here because it may be too long. It's have 3 dots instead of it. So first, build your run make, and when you run make, every goal that should get to dist directory get this callback dist for goals, and basically this produces the list in text file. uh, Here is an example, and every goal has a corresponding file. So this is only like on make step, it's only producing this text file. It doesn't compose this directory itself. Then you have this file, and if you run make dist, it executes Sung UI, not make. And inside this one, if the argument was dist, then environment variable dist is passed to all make files, and it gets to this specific make file responsible for this dir generation. Uh, Inside this make file parses previously generated text file and set dynamic pairs for uh, like dynamic goals for make files. So you can't find them like by text search because they are dynamically generated. And in the end of this process, you get this dir composed. Um, Here you can later analyze this code in more detail. Uh, mm, okay, and another step for this explanation. So the previous slide was how the process is working, but this slide explains how the actual makefile goals are connected. On the upper right part, you can see like a common makefile goal, just for reference, so you can remember. Maybe not anyone is pretty familiar with the syntax. So here you can see you call dist for goals for Droid core, and underneath it includes build target files package, which is our package used on the second step for producing OTA update zip. You can, as I mentioned on previous slide, after initial build, you will find this file, dist.mk, and can see this specific zip file connects to Droid core target. And this part depictures the actual name. Like you can't also search sources for this name because it's like dynamically generated based on your platform name and some settings. What you can see here is target files. This part is like static for all platforms, and it is assigned here into zip file. And the target itself, this is target for target files, make file target for this file. It include, and you can see after semicolon, you have more than 4 lines of prerequisites plus recipe, and most of them also have dependency on something else. So this is like pretty huge complex, and if you need to debug or check something, you can refer to this file name and investigate it further. And there is also like helper target just for manual invocation for testing. So some key points from here. This callback is used to add additional dependency for dist goal, and this line is assigning your actual zip file and composing target name for it. So after, let's get back. After you run this first command, make disk, you get target file zip on the output. And here is the internals of this target file zip, just for reference. You can see the list of folders, and the size is 1.8 gigabyte. It was in our case for our platform. And here is the next step. This one, OTA from title. First you run make dist, and then you run this step after you have target files for producing OTA update zip. Okay, in this one I will try to show in more detail on. I have a little bit more detailed here. So when you run this Python script, it's also have several levels of functions called, and also refers to other parts of build system. So first you pass target files as an argument and OTA update zip as an output. Here we follow code for AB update, because for other scenarios there is a pretty different code. After you pass the file to main function, it parses meta information in target files and understand we are going to have a AB update file. Then internally it passes this file to this function, write AB OTA package with Brillo script. The main steps here, first you extract metadata from target files. The metadata is basically like different settings and the prerequisites for producing a full-blown package. So the script parses this metadata, and later it uses and all some different prerequisites for generating first it generates payload bin, which is like the biggest part of OTA update. And for generating this payload, it calls different script from different part. And the interesting thing here is this script is from different project. So basically it extracts images and it squeezes its size by some specific techniques, like developed by Google because they like have understanding of how this image usually looks and what are the differences. And its name of this process is delta generator. So it compresses these images with some specific algorithm and provides the resulting patches. And on the output here you get payload bin, and it includes only partitions configured by meta information, which in turn was configured on build step on your device specific makefile. Here is also the information how it can be found in sources. So this payload bin is passed back to OTA from target files, And the payload bin is not enough. You also need to supply some property files for AB and for streaming. And only then you finalize all these things, because some of the later steps depend on or modify previous steps information. So you need to finalize them. Yeah, the process like not pretty straightforward maybe, but there is some reasons behind it. And then you get update zip. Okay, let's get back to. So after you go through this process, you get OTA update zip, and the internals you can see here. Just for example, the biggest file is payload bin, which was again produced by payload generator, and some files with meta information, and other files. For this one, we didn't know yet what is the purpose of these files. And update payload bin is a PACU binary file, which includes almost like essential things needed for providing the update. So its format is like also wrapped inside sources coded, but it is possible to find it. I will explain on the current slide. Um, so it's again it's produced by update engine payload generated. So we refer to its source to look into more detail. Uh, Update engine, it's a daemon designed for AB updates. It runs all the time alongside regular Android processes, but for user it is unseen. So payload file format you can find on this path underneath update engine sources in protobuf format. So here is a good example of Google reusing its previous technologies. And here's the config for all applications and libs, which is included in update engine. And also we find the place where different kind of logs can be enabled if you start to have some experiments with update engine. So unfortunately, it's not possible to fit a lot of information in one presentation, and many things are missed from here. It's just for setting the background for everyone for future research. And if you have some questions or perhaps for cooperation on OTA update projects, you can see my contacts here and contact me. And also, if any specific questions about OTA update, I will be available on Q&A session.